ARP stands for Address Resolution Protocol. IP addresses are given to computers to uniquely identify them in a network. Each computer also comes with a built-in identifier known as a MAC address, also known as physical address, which is unique to that device. MAC addresses are stored in the hardware of network interface cards, NICs, or network adapters. The length of a MAC address is typically 48 bits. For effective communication in a LAN, computers require both IP and MAC addresses. When a computer wants to talk to another device within the same network, but only knows the destination's IP address, it must also find out the corresponding MAC address. This is where the Address Resolution Protocol steps in. ARP helps to map IP addresses to MAC addresses. Why is it necessary for computers in a LAN to know the MAC address of the destination device? Watch till the end of this video to find out. Now, let's see how ARP works. Here, each computer has its own unique IP and MAC addresses. Initially, all computers start with empty ARP caches. ARP cache is like a table in each computer that stores IP addresses and their corresponding MAC addresses of other devices. Here, computer A needs to communicate with computer B. Computer A knows B's IP address, but doesn't know B's MAC address. To get B's MAC address, computer A initiates an ARP request by broadcasting a packet onto the LAN, like asking, "Hi, 10.0.0.2, what is your MAC address?" This ARP request will be sent to every other computer in the LAN. In this ARP request, computer A includes its own MAC and IP addresses along with computer B's IP address. Upon receiving the request, all computers check if the target IP address matches their own. In computer B's case, it's a match. Understanding that the ARP request is meant for it and that computer A is requesting its MAC address, computer B responds directly to computer A with an ARP response packet, providing its MAC address. Once computer A receives the ARP response, it updates its ARP cache with computer B's MAC address, associating it with the IP address. With both the IP address and MAC address of computer B in its ARP cache, computer A can now directly communicate with computer B. Computer B receives the data packet from computer A and processes it accordingly, completing the communication. Over time, if computer A and computer B don't communicate again, the ARP cache entry may expire. This helps keep the ARP cache updated and removes outdated entries. ARP isn't limited to just computers, it's used for other network devices as well, like network printers, routers, etc. Let's say computer A wants to send a print job to a newly connected network printer P. Similar procedures take place here as well, with computer A sending an ARP request broadcast and printer P responding with its MAC address. To view the ARP cache on your computer, open the command prompt, type ARP-A and press enter. This command will display the ARP cache entries, showing the IP and MAC addresses of devices currently resolved on your local network. You'll see a list of ARP cache entries, including the IP addresses and corresponding MAC addresses of devices your computer has communicated with recently. Here you can see two types of entries named dynamic and static. Dynamic ARP entries are created and maintained by the system as a result of ARP requests and responses that occur during network communication. Like we discussed earlier in this video, these entries are typically temporary and can change over time as devices communicate on the network. Whereas static ARP entries are manually configured and added to the ARP cache table. They are typically used to ensure that specific IP addresses are always mapped to specific MAC addresses. Static entries are not automatically removed from the table. You can add a static ARP entry using the command ARP-S followed by IP address and MAC address in command prompt with administrative privileges. If you need to clear the ARP cache, you can do so using ARP-D*. This command clears all entries in the ARP cache. In a local area network, knowing destination MAC addresses is crucial because most LAN protocols operate at the data link layer. At the data link layer, MAC addresses are used to address individual devices within the same network. Devices such as network switches, which connect devices in a LAN, operate at the data link layer as well. Therefore, in a LAN environment, when a device intends to communicate with another device using its IP address, it must first determine the MAC address of the destination device in order to forward data effectively. Thank you for watching. If you found this video helpful, please support us by liking and subscribing to our channel for more. Don't forget to enable notifications to stay updated on our latest uploads. Feel free to share this video with anyone who could benefit from it. See you in the next one.